Hello.
Let's go, Stacker.News!
Okay, so today we are going to discuss Web of Trust because a notable audience member has requested it and refused to accept me not doing it. It's going to be a whiteboarding session. I consider this part one. This is an introductory thing to Web of Trust and not an actual workshop. Potentially in the future, when the notable audience member gets back from a pilgrimage, we will do a workshop and actually code something. But this time we're just going to kind of figure out what Web of Trust is and why it's good and why it's bad. First, I want to define trust. I think that's probably a good idea. So Google says that, or no, this is DuckDuckGo.
I can give you a definition. I trusted that you would give a workshop today.
Yeah. Super does not trust my ability to come through with a workshop. It's the firm belief in the integrity, ability, or character, let's just say ability, of a person or thing. In our case, it's a person generally. So this is kind of important. Like we trust our car is not going to explode on our way to where we're going. We trust our friend isn't going to trip us as we walk down the stairs. Trust is important. It's pretty critical for how humans interface with the world. But it's kind of a tricky thing to do in a group. Especially among people you don't know. How do you scale trust? Computers allow us to gather more people in a shared virtual space than humans would otherwise ordinarily be able to gather. And therefore, trust kind of breaks down under those conditions. And one way to deal with this is to use a Web of Trust. There are other approaches that you could use, of course, to doing this. Like trust in the way we're talking about it is kind of a reputation system. Because your reputation is kind of trust, like people's firm belief in your ability to do something. That's kind of your reputation. If you go to a site like Reddit or Hacker News, they call reputation, and what they are is they're like a centralized entity minting reputation and saying these people are good given their behavior. And so that's kind of one way to do this. Another approach that is more appropriate for a decentralized context is Web of Trust. We'll go into the history of Web of Trust just like a little bit, but I'll try to I'm going to try to do like a toy demo of how Web of Trust might work. Using things that we kind of all understand. So we'll put everyone in a web here and try to figure out a Web of Trust. So Car, do you prefer Red Delicious apples or Granny Smith apples?
I like Granny Smith.
Okay, Car is a...
Honey Crisp.
We have two apple choices. Oh, you're a Red Delicious?
No, Granny.
You're Granny.
Yeah, I like Granny because it's sour.
He likes a sour. Okay, he's a sour boy. Super.
Red Delicious.
Super is a Red Delicious.
You can have this Granny Smith stuff. I don't trust you at all.
Red
You
delicious.
also put pineapples on your pizza, so questionable.
Toshi.
I like red delicious too.
Red delicious. Okay. Toshi.
I got it.
You, sir.
Well, my name is Phil.
Phil.
Like Granny Smith.
Phil is a Granny Smith. Austin.
Red.
Austin is red.
Also, I say that we actually attack and co-opt the Granny Smith people, but we can talk about that. There are others.
Topher.
I'm a red kind of guy.
Topher's a red.
You're red,
Nick.
I'll go red because that's closest to Honeycrisp. I think.
Yeah. Supposedly Granny Smith. Granny Smith.
Nick, are you CK or just C?
TK.
CK. Hey, it's you.
Do you prefer red apples or Granny Smith apples?
Jana.
Red delicious or Granny Smith?
A granny.
Oh, interesting.
Okay. So now we have it.
Does Nate cause a divorce?
We kind of have everyone's preferences here. What we're going to do is we're going to say that we're going to try to see how much we trust people to pick an apple for us. Is kind of what we're trying to build up a trust graph for. So Super likes red delicious apples, and he knows Toshi likes red delicious apples. So if he sends Toshi to the store to pick red delicious apples, he's going to trust him pretty highly. Like maybe 1 out of 10 times Toshi will pick a Granny Smith, and so he only trusts him 0.9 because he can't trust Toshi more than he trusts himself, and he trusts himself 100%. So we're going to give him a 0.9, and similarly with everyone who likes red, Super is aware that they like red, and he trusts them 0.9. For people with Granny Smith, he trusts 0.1. This is another 0.9. You trust 0.1 because maybe 10% of the time they'll pick a red delicious, and we can do that for kind of everyone. So where they match up, it's 0.9. Where they don't, it's 0.1. This is going to get messy faster than I anticipated, but.
Oh, wow. Need more color markers?
No, it should be all right. 0.1, 0.9. And yeah, this is n squared connections, so that's a lot. Anyway, but everyone's not directly connected to everyone. And this is kind of what you might expect. So like perhaps Nick doesn't know about Super's preference for red delicious. So yeah, these are also directional. I should note. It's Super's trusting Jana 0.1. Not Jana isn't trusting Super 0.1 necessarily. Jana might not know anything about Super. And so that's kind of what the advantage of using this approach is. If people don't know another person's preferences, we can use this trust graph to more or less deduce whether they should trust them to be able to make an apple decision for them. So let's say Carr wants to send someone to the grocery store to pick out an apple for him that he doesn't know directly. The only person available to go to the store to pick out an apple for Carr is, let's say, Topher, or Topher or Nick, or Jana. So he doesn't know Nick, he doesn't know Topher, and he doesn't know Jana. but he knows Phil. And so Carr trusts Phil to pick out his apples 0.9. But Phil trusts Nick to pick out his apples 0.1, and he trusts Topher to pick out his apples 0.1, and he trusts Jana to pick out his apples 0.9. So if we so one way you can do the way I do Web of Trust and the way a lot of people do Web of Trust is the way we determine whether we choose or whether Carr should choose Nick, Topher, or Jana is we multiply these edges as we go to each of these people. So Carr will ask Phil how much he trusts Nick, given that given that he knows he trusts Phil 0.9 already, he will multiply what Phil trusts Nick with, or by 0.9. And he will do the same. He'll ask Phil, hey, how much do you trust Topher's apple picking? And he says 0.1. And Carr will go and ask Phil again, how much do you trust Jana's apple picking? And it will be 0.9. And this is 0.81. What is 0.1 of 0.9? 0.09. That makes sense. 0.09. Okay. So so if these are trust metrics, who should Carr trust the most to go pick an apple for him? It would be Jana, because she has the highest trust score, and it fits too because she does pick grannies. Usually.
Would she be 2 degrees away from Carr?
She is 2 degrees away from Carr, 2 degrees separated.
Does that take into consideration in some Web of Trust model?
The fact that we're using decimal or numbers less than 1 already takes that into consideration. Because if you chain another person here with 0.9, yeah, it degrades as you get farther and farther away. Yeah.
But what is the ideal you're shooting for in the Web of Trust model though? Because here the ideal we're shooting for is what who will choose the best apples. But what's the real criteria? Who will make the best post?
Oh, I see. We'll get into applying this to Stacker.News in a bit, but it's an interesting question. Another thing I want to go over here is that's just, Carr potentially has multiple paths to Jana, or multiple people. And so perhaps he also has a path to, he knows Super's preferences, and Super knows Toshi's preferences, and Toshi knows Jana's preferences. So that's potentially another path for him to get to Jana and determine how trustworthy Jana's choices are. And so there are really, potentially many paths to Jana. And in this case, the path is 0.1 times 0.9 times 0.1 again. And while that is lower even than these other ones, you would take into consideration all of Carr's potential paths to Jana and somehow combine them into one kind of trust metric and compare that to other ones. It's just, just to describe a feature here. But there are problems, I think, with this representation. Does anyone know what they might be? Off of it. What is subjective? The apple preference is subjective, but why might this be a bad way to determine whether Jana will pick the right apple for me?
Limited options? Spammers.
So limited options is one, right? I shouldn't use this graph ever to tell me whether Jana will pick the right produce for me if she goes to the grocery store. So that's like, I think problem number one is like, this is a very specific example. This will only tell me among two apple choices what will Jana pick. And when Jana goes to the grocery store, she actually has a whole produce section to choose from. So when you're using this type of model, it's very important that you're like very specific about what you're rating people on, and not using those ratings to make choices that aren't consistent with the model that you're building. So that's like point number one. The other point I would make is we're not really evaluating whether Toshi evaluates Jana correctly or not. So I'm not only trusting that Toshi likes red delicious apples, I'm also trusting that he has the right information he's telling me the right information about Jana, and he's communicating it correctly to me. Because really, he might think Jana might actually like Granny Smith apples, but he might think that she likes red delicious. And so this model doesn't currently take into account that Toshi might be untrustworthy as far as his communication about what other people like. And what we care about is getting the right result. And so it doesn't take into account that we might be getting bad information from Toshi. So that's kind of the other downside to this model is it's not evaluating how trustworthy Toshi is when he communicates about other people. It's kind of making the assumption that he's perfectly trustworthy along that dimension. And this is also where PGP keys kind of have a bit of an issue, because if you're familiar with PGP keys, what you do is you go to a signing party and you say this person's PGP key belongs to them, but you also you're also tasked with assigning them a trust score, so that you can form a web of trust like this and trust other people that they have connected to their PGP key to, and you're basically trying to estimate how trustworthy their signing of other people's PGP keys are, and it's hard to evaluate that, and additionally, it's hard to even communicate what that means, because you might trust Adam Back 100%, but you might not trust his ability 100% to sign other people's keys. Yeah.
So is there a solution to this problem, or is this like a long-standing problem?
I think you just have to be more. I think the solution is you're more careful when you're constructing these models.
It's really interesting because as you're going over this web of trust, you're really close to how neural networks operate.
Yeah.
Only neural networks seem to have a solution to the problem you're describing. They use backpropagation in order to deduce who was wrong in the chain of trust, and to tweak the parameters based upon how wrong they were, how much wrongness they contributed to the wrong answer.
That's an interesting point, but I think you are in a neural network. When you do backpropagation, you usually have a set of test data that's properly labeled, so you can measure your error. In this case, I guess we could do some backpropagation to measure error here too, and so that is potentially a solution as well. Like we could send everyone out to pick out apples and see how many they come back with and compare it to the actual trust scores that we have and backpropagate and get a better result. But that data might not be available to you, and then maybe as new people join, I'm not sure, you can't really apply all of that data you've gathered to the new people. You would need to gather new data from them. Yeah.
How do spammers attack this? Bad actors.
For this toy example, I guess you would you would tell someone like Austin you like grannies. Like I'm a spammer. You would be like, I like grannies, but you don't. You only pick out, like you work for the red delicious oligopoly, and you're looking to take over the world, and you tell everyone you like grannies when you don't, and then when you go out and you buy apples for them, you buy only red delicious. That's how you could attack it. But we'll get so what does Stacker.News do? So this is kind of just an overview of Web of Trust. So basically you end up with all these links to people, and then you kind of multiply them together, and then you kind of figure out who you trust more based on multiplying them together. This part here that I kind of hand-waved over, where you're combining these, where you have multiple paths, this becomes like really important as your graph gets really big, and it's actually kind of a big mathy problem. Where you do a lot of probability stuff, like probability theory stuff. Yeah, set probability specifically.
Sorry, going back to the attacker real quick.
Yeah.
Isn't this like how Web of Trust kind of like is designed to kind of eliminate some of those problems though? Because like that spammer, he's probably going to spam for all like however long before it's kind of realized that this guy who claims to like granny is only buying red delicious, and then it's like his trust score goes way down, and then he's kind of no longer spamming.
Right. So he told me how a spammer would come in here and like identify himself maybe, or maybe he would create a bunch of entities and say he likes grannies and buy red delicious with them. But ideally how you would prevent it is Austin would label this trust path 0 to him. And then anyone else that's connected to him also learns that he's a spammer and labels him 0. Or he enters the system with 0 trust, and over time, by picking grannies consistently in his behavior, you begin to tick it up to 0.1, and so on. Yeah. So that's how it prevents it. But I'll describe how I do it in Stacker.News, and it might.
Zero trust, then he never goes back then. No one's ever going to send him if they all trust him 0.
Yeah, but people who are directly connected with him might want to do a test with him and see whether, yeah, might give him the grace to have an experiment. Or maybe experiments cost you $0 as the person who's buying apples, which is the case on Stacker.News.
Well, spam attack isn't necessarily a spammer entering a trusted network, but a spammer creating a trusted network of their own, and then using that to attack the real botnets. Yeah.
Yeah, so that is a way to spam.
That's how page rank was spawned for a long time. People create a bunch of fake websites that back into each other.
Yeah.
Create fake webs of trust.
Yeah. We're going to take a short break while I get a piece of gum, and then it'll be
Yeah? Okay, you're good.
all right. I'm good.
Sorry, did you say you had her?
Okay. So with the toy example in mind, I will describe how Stacker.News' first naive implementation of Web of Trust worked. Given that you have a way to construct a graph, you have an algorithm for finding paths to people on the graph already. The real hard part in building a web of trust is determining, for a site like Stacker.News, how do you determine the trust level between two people? That's like that was like one of the things I struggled with initially. And my first naive approach to it was, let's say we have Carr on Stacker.News, and the first naive to exactly how it worked was Carr has liked, and there's Super on here, Super posts. How many items has Carr liked of Super's? And if Carr eventually likes 21 items from Super, he is considered maximally trusted by Carr. That's basically how it worked, which is very naive. Yeah, but if he likes 20, and it's 21 number of posts liked divided by 21, well, there's actually something. It was max 0.9, or no, it's min. No, wait. I don't actually remember what, I mean, I'm trying to remember exactly how I would write it out. Oh, that's right. Okay, it's 0.9. 0.9 times n divided by 21, and min basically is what it is. Is how I would write it here for you guys. But basically, like this basically says the maximum amount of trust that Carr can have for Super is 0.9, and it's determined by how many. This n here equals the number of items that Carr has liked of Super's.
Your end looks like a U.
I'm sorry, I don't write the way you like. But that was basically it.
I like it. It just looks like a U.
Why didn't that work, Keyan? Is it because it was just too simple?
It's it's very gameable. So it involves all it involves is Super posting roughly 21 times and Carr liking all of them. And then now Super has maximal trust. And so it's very naive. I did a small solve for it in an in-between stage where I had it decay. So over time, like roughly every month, the value of these likes would drop about 10%. And so if you hadn't liked anything new recently, this trust score would drop roughly by 10% every month. But that's still pretty gameable. Maybe Carr is nefarious. He's evil Carr, and he creates an account evil Carr 1 and evil Carr 2. And he posts from these two accounts, and he upvotes them all. And now Stacker.News trusts Carr a lot. And let's say because Stacker.News is liking a lot of Carr's content, and so Carr upvotes these a lot, and he has 0.9 here. Now Carr has a lot of power because he's built up this group, this cabal of trust. Right now, yeah. So as we described in the Apple example, it's Carr was picking who to buy him an Apple, but we could have also we could have said who does Toshi want to buy him an Apple, and we could have done that for any individual. That's the benefit of using a web of trust, is that it's relative to the person asking the question of who should I trust? Versus a reputation model like Reddit or Hacker News, where it's an absolute score, and there's only really one point of view.
Yeah, then it becomes like mine, like it's just,
It's like very centralized in.
That's the problem with them.
Yeah, I don't know where I put the.
Oh, right behind. On the floor.
Oh. Anyway, that was kind of the first way I ended up doing it, and right now, yeah, Stacker.News is I would say it roughly works similar to like Reddit or Hacker News in that there is just one point of view. It's currently Stacker.News' point of view, but it uses an algorithm that can be reworked so that every user has their own point of view, and we intend to do that eventually. And then this becomes less of a concern when Carr does this, too, because other users can be like, I just don't trust Carr anymore. I see him creating this cabal, and yeah. But this is how it initially worked, and just a little too easy to game. It also doesn't. We talked about this with the toy example, but this also doesn't communicate. Like what I'm using this for in Stacker.News is what's showing up on the front page. And Carr liking Super's content doesn't tell me anything about how good Super's ability is to upvote content. And so it's not measuring the right thing. All this tells me is how much does Carr like Super's content. It doesn't tell me how much does Carr like what Super likes. And that's what I care about. I want to show people things that we all agree is great content.
Yeah.
And this metric here does not tell me anything about if Super has good taste in the content that he likes. He might post good content, but it doesn't tell me anything about his taste to pick other people's content. And so that's like another reason why this metric is subpar. So what I do now is a little more complicated, but let's start out with Austin this time. And we have Jana. And now we need to, again, the hard part of this is determining this link value. But how we do it now is, let's say Jana likes story A, C, and E. She likes them. And then Austin likes stories B, C, and Q. I was going to write D, but Q now. And so these are stories that he likes.
None of the Q goes on the right side of the Q.
But I'm trying to figure out how much Austin trusts Jana. And and what Austin can look at is like, well, I've liked C, and Jana likes C. So, but she also liked two things that I didn't like. So I maybe trust her if we extrapolate this out to infinity, right? Like a massive number of trials. We can say that I trust her about 30%. 30% of the things that Jana likes, I end up liking. So I trust her 30%. Yeah.
That's the difference that started with the apples.
Well, that's only if Austin sees every post that Jana sees, because like it might be he never saw it.
Yeah.
It shouldn't count as a down, like shouldn't hurt trust.
What you don't want is false positives, I think, more than false negatives. On Stacker.News right now, it doesn't matter. And really, I don't know. I can't know how Austin feels about A, so I can't use it as a data point in his in any way. I can only assume that he either didn't see it or didn't like it. Regardless, Jana is. Think about it in like a more familiar context. You go out with a friend to a bar, and you can see everything he does, and you have a point of view of him there. But you know he spends the other half of his time at another bar doing other things. And so you can say you trust 50% of his behavior because you saw 50% of it, and you think that's all trustworthy. But the other half of his time he spends at this bar where you don't get to see it at all. I could either assume you trust 100% of his behavior based on the 50% you've seen, or be more conservative and say you only trust 50% of behavior because that's what I actually know. And this isn't that. And while this might seem low, Jana has a bunch of other relationships with people, and so she might have relationships with people at point 2 and point 1, and maybe someone really trusts her a lot. They're also liking all of these things too, and they trust her point 9. And then what a person does who perhaps has all of these paths to Jana is they go and they combine these together to construct a trust score that's going to be greater than 0.3 or 0.2 or 0.1, but perhaps less than 0.9. And so in that way, I think you get a pretty decent point of view of how trustworthy Jana is at upvoting content. Yeah, this is a little more complicated than like looking at 3 scores, but it's going to be a little bit difficult to communicate. But we use something called binomial proportion interval.
What does binomial mean?
Means like bimodal, like two, like there's either success or failure, is my understanding. It basically allows me to take a look at a very small number of cases and then with some statistical certainty or some statistical confidence be able to say from a small sample like this, how in the future, if we extrapolate out from this, what is the likelihood? And that's why I said, like, if we go out an infinite number of cases and Jana likes only 1/3 of the things that Austin like, he only trusts her 0.3333. Yeah. Trying to think of.
One question, kind of going back to the toy example, there was paths, right, with multiple jumps, but from Stacker.News' perspective, really, you have all your users one step away. They're right in your database. So you can take the score of me and see everything that I liked, and you can take the score of Jana and see everything that she liked.
Right.
And you can do all of this yourself, but where does it evolve to where? And you could give us each catered timelines based off of that. But why would we need to be in a route or in a graph with other people in order to determine that for ourselves?
Like what's the benefit of a graph?
Yeah, what's the benefit?
Scale is.
Why can't you just serve?
Because you might not be interacting directly. You might not have direct relationships with certain people whose perspective you might want to be influencing. Your perspective is really the reason. Like, yeah.
Yeah, the word for this is discovery, right? Like,
Yeah.
there's like a million YouTube videos. How are you going to find the ones that you're interested in? You're not going to watch all of them.
Yeah.
Have relationships with other people, have them look for you.
Yeah, you've been watching videos on cookie making, but I'm sort of trying to broaden your point of view a little bit to include baking bread. And so this is like a way for me to kind of get an idea of what you might like more generally, because you might not yet have interacted with Super yet, but you've interacted with Jana, who's interacted with Super. And so I can use that to determine. I can bias what you see with Super's point of view through Jana, and therefore you get content that might be more relevant than you would even select for yourself. Is kind of the idea.
I see. So it's like me and Jana agree a lot
Yeah.
on things, but then so does Jana and Super.
Yeah.
So might as well give Austin some Super.
Yeah. Yeah. That's kind of
I
the.
still don't see why you can't just like from the Stacker.News level just deduce all of that.
Well, so how this actually works is it's me as a user. It's me, Koob, as a user. And what is my relation, like this, my relationship to you is determined the same way Jana's relationship is to you. Or your relationship to Jana. And so maybe I have a 0.5 relationship with the content that you like. And I maybe don't have much of a relationship with Jana's content. Maybe my direct relationship with Jana is actually 0.1. But really, this would tell me that I should have a higher trust of Jana than I do. And so when she goes to influence ranking, I give her more trust than I would otherwise, because I trust you quite a bit to pick good stuff. I've just been absent maybe a lot from the things that Jana sees. And so my trust of Jana's voting gets higher.
Is there a place that uses this type of thing now, Keyan, like out there on the web? Is this kind of what Twitter uses and some of these bigger sites like Facebook? Or
I mean, I think a lot of reputation systems kind of begin looking somewhat like this, but I think it's what's nice about this is it's transparent and explicit. Like I can go and see how much every user is trusted, and how much they'll be able to influence ranking. But when you're on Twitter, the likelihood that you see a post is influenced by a variety of factors that I think are largely controlled by neural networks, probably, that are mostly opaque, I would say.
Yeah, it's also operable, so you can like go in as an individual user and say, oh, disregard.
Yep.
Like, influenced by this person, and then computations can reflect that.
Yeah, great point. Yeah, that's the benefit of it being like it's fairly simple and naive, and you can at any point I could say, you know what, Jana, I don't like Jana's taste anymore. Her taste has gotten unappealing to me, so I don't want to trust her anymore. And so yeah, so there's benefits like that.
So this is kind of like you're still building an algorithm. You're still taking in the same data, or maybe a lot of the same data that like Twitter would be, but you're putting it through this simple algorithm that's like it's transparent. Versus like on Twitter, it's going to go into a black box. They're going to take all the data. How long do you hover over this? Do you click on tweets with these words and all of that, and it just throws it into a black box AI algorithm that will just make my timeline. And you can never really look back at that and say, why did this happen? And so therefore scaling it or doing anything with it just means throwing more data into it.
I mean, I think you can probably throw different kinds of data into it, and you can change the tuning parameters, like how much does the hover over affect the ranking relative to the liking or the retweeting or the follows. But I mean, to be honest, I don't know much about how their algorithm works. But they are using some metric to determine what you see, and you know that we share. We're using metrics to determine what you see, but it isn't as explicit as like this user has this type of relationship with this user, and that's why we're having them see the things they are. But another kind of point about this is this Jana liking item C only counts for Austin and Stacker.News' algorithm if she liked it before Austin did. So so you really only gain trust if you're predicting what other people like. And it doesn't count against you if you like it before them and they like it too, but that's the only way, or that's like a slight variation to make it a little less gameable, is you are ahead of people in predicting what content is good. And that makes me trust you to basically put things in my feed. Yeah.
So what are some of the ways that you can lose trust?
It's primarily by by liking bad content. So content that I don't like. If you keep liking.
How do you communicate that you don't like it?
Or I can, by not liking it myself.
I see.
So if Jana, if Jana came along and she voted for D now, and I didn't vote for D, then the score drops to 0.25. Do you see? Like her behavior becomes untrustworthy. I trust her less.
What if you just didn't see D?
Doesn't matter. I can't. I'm not. I have to be conservative in my assumption, right? Like I don't want to trust. Like I'm mostly concerned about trusting a heart surgeon who's bad at doing heart surgery, rather than not trusting a heart surgeon who is good at surgery.
So I should like everything on Stacker.News so that I don't give anyone a bad rating.
Yeah, you could build. If you liked everything on Stacker.News, your trust relationship with everyone would be very high, like in terms of you trusting them. But in terms of other people trusting you, it'd probably go to 0.
Why not? I'm giving them money.
You are giving them money. But should they trust your decisions as to what you like? I don't think so.
Like in aggregate, people would just like each individual who liked one or two things that would like you for that. But everybody else who didn't like those things would like wouldn't like you.
Yeah, Topher.
So the interesting thing here with Stacker.News specifically is like in comparison to Reddit, you really only get one vote. But with Stacker.News, your vote has an amount attached to it. So do you use that to weigh like how much trust is increased?
Right now I don't, but this is something I'm going to be working on soon, and that'll be interesting to play around with, because I basically have an additional parameter that costs something to send, or it costs something, that attestation of I like this thing, like as you amplify that, it costs you more and more. And so it could be useful to use that and perhaps make this a more reliable metric. And I should say this is like not very good right now. This is like iteration v.1.
I think the fascinating thing is that, to me, all of this just goes back to you're trying to find the absolute most, like the best content.
Yeah.
All of that is in line with that, not even assumption, it's like that, this is what we're aiming for. And I think that's kind of what that does, at least how I'm seeing it in my head. It's like, oh, okay, so it doesn't matter if he likes everything. Doesn't mean it's the best content, though, because you're taking a lot of considerations,
Yeah.
variables into it.
Yeah. Yeah.
That's kind of
So
cool.
did I just hear that like you're gonna play around with the idea that like you can weight as a user how much you like the content?
Yeah, with sats.
So like if you're like, so it moves forward from just liking the content to like, okay, I like this content, but I like this content worth like 10 sats, and I like this content worth like 10,000 sats, and that somehow now changes the way that
Yeah, we can that becomes a reliable thing you can say, because on Reddit it wouldn't cost you anything to upvote something 1,000,000 times, because an upvote is free. That's why they only limit you to 1 like. But on Stacker.News, it actually costs you money. Or right now, you could create your own an account you're tipping yourself, and then it doesn't cost you anything. But we're going to take a little fee of that to make this game theory work, so we can actually derive signal from
so if I
how
like
much you tip.
more, or I pay more.
Yeah.
But if other users don't like it, it's then weighted against me more? Because I've now said, like, if you're weighting what I do and don't like, then I would assume that the reverse correlation is that, like, if people are like, well, you've now staked 10,000 sats on this, and you're an idiot. I don't like this at all. Like, a lot of people don't like the, like, highly paid post. Is that, like, weight in the opposite direction?
I don't know. I mean, there could be some normalization of it where it's like bounded, where maybe if you put a lot of money into it, it counts for only 2 votes in favor, and if someone has 1 vote in favor, maybe maybe it's a wash in terms of how it affects trust. Maybe it doesn't affect it at all. Your trust stays the same. But it's again, it's just like another thing. What I'm looking for is like reliable signals that people are doing things. Like that's mostly what I'm trying to tease out. And the fact that they gave more money is one, and might be helpful.
So this seems like something that you wouldn't normally expect like a platform to give you, but it would be interesting like if as a user I had access to these parameters.
Yeah.
So like I could decide how weighted like a particular amount of sats is on a post versus me liking it or implicitly disliking it. But I get to decide like what that weight is because it would be fun to play around with. As a
Yeah.
user.
No, that's a good point. Exposing, especially in a world where each Stacker.News user has their own perspective on the platform, that'll definitely become an unlock. Is where you get to tune all of these things yourself. You get to tell us how much you trust supers likes. You want us, even though maybe you wouldn't, your behavior isn't suggesting to us that you trust supers likes. You want to tell us explicitly that you do. And you want to see his content, and so you want us to boost your trust to him, and that's a totally valid thing to do. But I think, yeah, I don't think I have much more in terms of. I didn't have anything to begin with, but hopefully maybe next time we can actually walk through how to in code how to like code this up, but.
Yeah, we're at 50 minutes, so I think, dude, that was amazing.
Good.
I really loved it.
Okay.
Yeah, we're good.
Thank you.